For about 4,000 years, the ceiling of human construction was set in stone. The Great Pyramid of Giza stood at roughly 145 meters, providing a strict physical limit to how high we could reach. As the industrial age introduced new materials like steel and iron, humans began pushing upward again. Progress was methodical. New structures, such as the Eiffel Tower, would typically edge past their predecessors by conservative margins of 5 to 10%. By the late 1990s, the competition for altitude shifted from the United States to Asia. In Kuala Lumpur, the Petronas Towers claimed the title at 452 meters, adhering perfectly to the historical pattern of incremental growth. By 2004, the record reached Taiwan. Taipei 101 crossed the half-kilometer mark, standing at 510 meters. It was the natural next step. This chart shows the progression of the world's tallest buildings. You can see the steady stair-step pattern up until Taipei 101. Then Dubai announced the Burj Khalifa. It shattered the trend line, jumping a massive 62% to reach 828 meters. The margin was so extreme that the tower effectively ended the skyscraper race. It was a psychological wall, a height so daunting it discouraged immediate attempts to surpass it. Naturally, the announcement triggered an immediate reaction. Within a few years, developers in Saudi Arabia and China unveiled plans for their own megatowers, aiming to cross the elusive 1-kilometer mark and reclaim the title. Those ambitions crashed against reality. Today, those sites sit as abandoned foundations and half-finished concrete skeletons, surrounded by bankrupt investors and halted supply chains. Since its completion in 2010, dozens have tried to beat the Burj Khalifa, and every single one has failed. The vertical crawl of human construction has completely stalled. Why did our upward momentum stop exactly at 828 meters? To understand what is killing these future projects, we must perform an autopsy on the engineering of the only giant that actually survived the climb. In the early 2000s, the future site of the Burj Khalifa was nothing but a vast, undeveloped stretch of sand. A structure weighing 500,000 tons cannot sit on loose desert soil. Without a rock-solid base, the sheer mass of the building would cause it to sink and eventually collapse. This diagram illustrates how the engineers bypassed the search for bedrock. They drove 192 massive concrete and steel piles 50 meters deep into the earth. Rather than resting on a hard surface, these piles stay suspended, gripping the sand around them through pure surface friction. With the base secured, the structure encountered a more subtle threat in the upper atmosphere. At 800 meters, high-speed winds generate rhythmic, swirling vortices, energy patterns capable of vibrating a tower until the steel simply snaps. This highlights the buttressed core. From above, the building forms a Y shape, supported by a hexagonal hub. When extreme winds strike, they don't hit a flat wall. The unequal wings slice the wind, breaking organized forces into chaotic, harmless swirls. The architecture neutralized the sand below and the wind above. But the construction process itself faced an environmental threat that nearly destroyed the materials: the boiling desert heat. Pumping concrete is a race against time. In Dubai, summer temperatures easily reach 50 degrees Celsius. Under that intense heat, liquid concrete would cure and harden inside the delivery pipes long before it ever reached the upper floors, turning into useless blockages of stone. To keep the concrete fluid, the crews adopted a strict nocturnal schedule. They only poured during the cooler night hours, heavily mixing the liquid concrete with massive amounts of ice to lower its temperature. Even in the cold of the night, pushing thousands of tons of thick liquid a half-mile straight up required specialized machinery. They utilized 3 of the world's most powerful pumps, working relentlessly against gravity. Over 330,000 cubic meters of concrete reached their destination through a highly orchestrated balance of ice, night shifts, and extreme pressure. The final physical hurdle awaited at the very top. To complete the tower's silhouette, workers had to install a 136-meter steel spire weighing 350 tons. At an altitude approaching a kilometer, the air is too thin and the winds are too erratic for cargo helicopters, and no conventional crane could lift that much weight from the ground to the summit. The engineers bypassed the exterior entirely. They constructed the massive pipe in small sections inside the hollow core of the building itself. Then, using heavy-duty hydraulic jacks, they slowly pushed the 350-ton spire up and out through the roof. Through sheer mechanical ingenuity, the builders solved every physical riddle the environment threw at them. But the reason no one has surpassed 828 meters in the years since isn't because we lack the engineering. The ultimate barriers aren't made of steel. Structurally, the designers of the Burj Khalifa state that by using advanced materials like lightweight carbon fiber and modifying the buttressed core, we could theoretically build a tower more than 2 miles high. The first real wall we hit is biological. Rapidly ascending thousands of meters forces the human body to experience a severe drop in air pressure. Without heavily reinforced pressurized cabins and floors, like an airplane, occupants would suffer from severe nausea and altitude sickness. Pressurizing an entire skyscraper is astronomically expensive, and that leads to the true killer of megatowers, the economic reality of elevators. The taller a building gets, the more elevators it requires. Eventually, the central core becomes so thick with elevator shafts that there is practically no floor space left to lease for offices or apartments. The push for the sky didn't stop because the concrete failed or the foundations cracked. It stopped because the return on investment collapsed. The Burj Khalifa exists because its financial logic was entirely different. Dubai pursued the project not for a direct profit on the lease space, but for the global attention it would generate. The tower was constructed as a spectacular loss leader. The true profit came from transforming an oil-dependent desert city into a highly desirable global economic hub, exponentially inflating the real estate value of every surrounding block. That specific alignment of vast wealth and desperate ambition is almost impossible to replicate. Most governments view these extreme megastructures as a massive waste of public funds. China, for instance, recently passed a strict law banning the construction of any building taller than 500 meters, firmly capping the era of vanity projects. Projects following the Burj Khalifa fell victim to basic economics. They sit unfinished, leaving this single structure piercing the clouds, unchallenged. The mystery of the unbroken 828-meter record is simply this: the Burj Khalifa was a one-time anomaly, an extraordinary alignment of infinite funding and unyielding ambition that the world may never see again.